الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
Hello everyone, thank you for joining today's session on the machine learning project workflow. My name is Reina Baba. I'm a technology and experience senior consultant, and today I will talk to you about the machine learning project workflow and a lot of technical challenges that will come up when you're dealing with machine learning, but also, and I think the interesting part is going to be some of the business challenges that you might face in real life and how to tackle them. So in terms of the agenda for today, we'll talk about framing the problem, getting the data, preparing the data, exploring it, and doing some feature engineering. We will then talk about creating the model, hyperparameter tuning, and finally presenting the results. We will not talk about the deployment or taking or launching the machine learning model. We are just going to cover this, and I promise it's going to be a lot of insights into the business world and the technical world, of course. So to start with, of course, we're going to start with framing the problem, which is a very simple step, but it's often underestimated, and it has a lot of impact on everything that follows. So when we talk about framing the machine learning problem, we need to think about the big picture and the business objectives first. So when we talk about the business objectives, some of the things that you need to ask yourself in the early stages of your machine learning project is, what is the business objective of this project, like anything else? And also, what kind of impact do you want to leave? Are you trying to deliver something that will cut costs for the company or the client, or you're trying to generate more revenue from this machine learning system? So you really need to think about the output or the final product and work backwards from there. And of course, in early stages, you will be able to identify what's the right machine learning system. Is it supervised, unsupervised? Is it a regression problem or a classification, which I'm sure all of you will do. Now, I will talk about some of the things that I found most challenging in my experience and how to address them. Because, of course, if it's straightforward, it will be an ideal case scenario. So in a best case scenario, you will have someone, whether it's your manager, your, let's say, client, who will tell you, this is exactly my problem and this is exactly what I need you to do. But in real life, we solve a lot of complex problems, and problems are not very straightforward. So again, in an ideal case scenario, you will want to have exact answers, but when you hear a lot of consultants, when they work for other companies or even internally as a support function for a bigger company, they say that the stakeholder never tell me what they want. They're never clear. And that's very common, and we can't really expect people to tell us exactly what they want. And this is where I think you and your team come in to dissect the big complex problem into smaller ones, and then you identify how machine learning can solve that. I'm going to give you more examples to put this in context, but I want to mention one of the really useful methodologies that I use in my work that helped me frame the right problem is called design thinking. And I'm not going to talk about it in details because on this channel there are plenty of videos and tutorials from GDEs on design thinking. But basically, in a nutshell, design thinking is a technique that helps you identify a problem worth solving, and it helps you really dissect the problem into something you can tackle. So let's say, and I'm going to give you now an application of design thinking and how it's relevant for AI or for machine learning. Let's say you are approached by a client, or your company tells you, we are failing to retain customers, and this is leading to a decline in revenue. Now, normally, if you are just going to take that information, you are going to say, okay, so now I need my machine learning model, as it seems to predict who or which customers are going to leave the company and leave us, and how do we retain them, basically to maintain the revenue or to increase the revenue. And that seems very simple, and sadly it's never like that. Clients will never come up with a very clear problem. It's going to always be a very complex problem, and then you need to do some digging and understand what is it that is really the root cause of the problem. Because if you honestly go ahead and just focus on predicting which customers are going to leave, it might not be the right problem to solve, and you might end up wasting a lot of time fixing a problem without focusing on the issue. So let's say you use design thinking. And again, in a nutshell, design thinking is a way to understand the root cause of the problem. And it's very, very simple. You can start with some techniques. So there are different ways to build an understanding of a problem. One, you can do some observations. So you can actually go to the physical store or to the physical location if the client has one, and observe what's the issue. You can see, for example, here customers are frustrated. So let's say you go into the physical space. You notice that customers are waiting long in a lot of lines and queues, and the employee is not efficient. They're not doing things quickly, as if they're not trained or as if they're new and they're overwhelmed. You can also see, for example, that there is only one employee for a very large group of people. So you start getting this data in, and that's not something that's always given to you. That's something, and maybe it depends from company to company. So in some companies or in some teams, you will have people that are doing this for a living and you can rely on them. But sometimes when you're starting with a new team, or when you're doing something, or when you work with a very small company, sometimes we end up wearing multiple hats, and that's very common in consulting. We end up doing very different things to make sure that we're solving the problem effectively. So let's say you don't have UX researchers. It's very useful for you to know some of these skills, or to be aware of what can be done to understand the problem. So as I said, design thinking is a methodology. One approach is to do some observation. Another approach is to just talk to customers. So of course you have interacted with surveys, but you can directly speak to customers, of course, with the authority of your client, or with the approval from your client. And then you can do also some call listening, for example, again with the right approvals. And maybe you will start to identify that employees are not trained, or they don't really know how to answer the questions for their customers. So then when you dig deeper and you talk to your client and your stakeholder about all of these issues, you start to realize that a lot of the employees are leaving really in a very quickly and in an increased rate, which is leaving your client without trained employees, and they're now having to recruit really quickly, put them, because of course they can't stop the company. So with minimal training, they're deploying their staff and they're doing operations as normal, which is impacting customers, and then customers are leaving. So all of this story is just to tell you that one statement will not be enough for you to start with your machine learning project. There will always be a lot of data that you can gather. And one of the mistakes that I felt I went in before in my experience is that I always looked for quantitative data. So I never really understood the power of qualitative data, and just being able to do some research and digging to understand what's the underlying problem here. So that's one of the skills that I really recommend for people in the machine learning world, because it can really be helpful. Again, it's the number one step. And as you can see, it completely changes the project. So instead of now predicting a customer churn and how we can retain them, we are now going to look how much we predict who is going to leave in terms of employees. And then we're going to try to retain these high-performing employees to maintain a good customer satisfaction, customer experience, and that will solve the big problem. So that's one example of reframing the problem. In my experience, as working with other companies and working on complex problems, the framing the problem was never a straightforward process. People, and it's just normal human behavior, people will never tell you what they want because they don't know it. They will give you some challenges they face, some data. They'll tell you everything they know, and then it's up to you to really frame the problem and to understand what is it that you need to focus on and help them with. Now, that's a quote from Einstein that proves that too. So Einstein said, if I had an hour to solve a problem, I'd spend 55 minutes thinking about the problem and 5 minutes thinking about the solution. So this is really to emphasize how important understanding the problem is, because it impacts everything after. And a tip from me is also to understand that, of course, machine learning is not a magical decision system. So, not every time you have a problem, you can just throw machine learning at it. It's really important to understand data, and it's an outcome again of data, like in terms of talking to people and understanding what's the issue, and also the data that we will talk about later, which is going to be directly fed in our machine learning model. And also, it's important to understand the objectives, because these objectives become your North Star. So it's every time you're going through the process, you need to make sure that you're answering the big exam question. So that's the big step from me. The other one, which I've also faced a lot, is don't be afraid to launch a product without machine learning. So even when you're doing the first stage, which is framing the problem, sometimes you might realize that machine learning is not the answer to everything. And that's fine. Sometimes it can be very disheartening, because that's what we're passionate about. And I'm sure everyone in this community would love to try and experiment, and it will be you might even find something boring if you don't need it, and you might just need to build an application. But sometimes an application is the right answer. Sometimes it can be a physical solution. It's not even digital. So it's very important to really question whether you're thinking of the right solution for this problem. And that's another thing that a lot of people, and even me personally, I am like, I made that mistake, because then you don't really deliver the best impact or the highest impact. The other thing as well, when we talk about machine learning, especially with different people who might not necessarily understand machine learning, but we might help them with a machine learning project, they will not really understand it if we're just talking to them and presenting to them and telling them what we could do. It would be really helpful if we can present a prototype before kicking off a project. I find this very helpful, because people really understand things better, and they communication becomes easier when they visualize things and they see how it works. So even if it's a prototype, even if it's not a fully functional solution, it would still be good to show your stakeholders or the people you're working with what is it that they can expect. So that's it for the first part of framing the problem. But now comes another important part, which is um, choosing evaluation metrics. But one thing before we jump to that, I want to highlight that we are going to talk about employee attrition. So, for two reasons. One, you probably have heard of the Great Resignation. So now employee attrition is becoming increasingly a problem after the pandemic. A lot of people have been leaving their jobs. And because people now are reconsidering different things, right? The pandemic probably made people realize different things, and people have different priorities. So that's one thing. The other thing is that, generally speaking, even before the Great Resignation, employee attrition or employee churn is a huge business issue, because it costs business a lot to recruit people. So that's a lot of effort, like a recruitment effort in terms of time and money. Also, training employees is costly. So after you train the employees and they know the business really well and the ins and outs of things, they then leave. So all of this is costing businesses a lot of money all the time. So of course, there are a certain level of turnover. It becomes unhealthy for a business, and it becomes a huge cost. Similar to the example we've seen before, like when it's affecting your everyday operations, that becomes a very big issue. So we're going to tackle that, because almost every organization has lots of employees that they like to retain. So I hope you find it relevant. We are going to talk now about selecting a performance measure. And to do that, you really need to understand what this model will be used for. So how will it be in the end? And again, as we said, we need to walk backwards. And also we need to talk about the final product, even if it's not existent yet, even if it's going to be a system that's not developed, or maybe it's an existing system where the machine learning model will be integrated with. So all of these are important, because we need to select our performance measure based on these answers. Now, I'm going to take a pause and I'm going to hear from you a little bit. So I want you to scan this QR code. We're going to move to a platform where I'm going to ask you some questions and get some interactions. So let me take you to this one. So I'm going to give you a couple of minutes to enter. You can either scan the QR code or you can go to menti.com and use this code when you are prompted to put the code. Hopefully this works. If it doesn't, we're just going to carry on with the slides. Okay, as I'm waiting, I'm just going to tell you about the plan for the next few minutes. Now we're going to talk about the challenges with imbalanced data sets, because as you know, when you talk about employee attrition, it's normal that you'll have most of the people in the company, they will stay, and only few of them will be leaving. So your data naturally will have lots of observations about people who eventually are part of the company and they stayed with the company, and some observations of people who left. So we're going to talk about the challenges that have on our project, and then we're going to carry on with the other steps. I'm going to give you one more minute. Okay. All right. So I'm going to start now. If at any point, if you weren't able yet to scan the QR code, at any point in this, you can just go to menti.com at any stage and you can enter this code. So if you are still doing this, don't feel like you're left behind. You still have time to do that. Okay. We're going to start with the challenges with imbalanced data sets. We're going to talk first about their definition. So what are imbalanced data sets? And then we're going to talk about what this means for evaluating the model that we're about to talk about. So my first question to you, now we have everyone here, is what are imbalanced data sets? So you'll have three options and I want you to choose the right one. So imbalanced datasets are datasets where the target class has more than 10 classes, has just 2 classes, or has an uneven distribution of observations. Five seconds. Time's up. Okay. So imbalanced datasets are datasets where the target class has an uneven distribution of observations. So what does that mean? This means whenever you're dealing with a situation or with examples where you have lots of observation from one class or from one category versus the other. So let's say let's leave employee attrition. If we talk about detecting fraudulent transactions, if you're dealing with a data set with transactions, you are very likely to find almost 90% of transactions that are non-fraudulent and 10% or less transactions that are fraudulent. So this is an uneven distribution. You're talking about 90 observations that are non-fraudulent and only 10 that are fraudulent. Same thing goes for like some diseases. So if you're detecting a specific disease in the population, you might find most observations are healthy and a small one is unhealthy. So when we talk about attrition, that's one of the things we're going to face. As I said, you'll have a lot of observations about people who stayed at a company. So if you are still employed, let's say, or if you can think of a company, imagine you're gathering data about the employees. Let's say they have 1,000 observations. It's likely that they will have 800 or let's say 900 observations about employees who are still with the company and only 100 for employees who left. So that is the problem with imbalanced data set. Now, what does that mean? Why is this a challenge? I'm going to talk a bit about the challenges and then stay on the platform because there will be more questions coming up in a few minutes. So first, I'm not going to talk very much in details about imbalanced data sets because I noticed that there will be a session about it, I think, in a day or two on the same channel. So, and I'm sure that this session will focus on very much on details around the techniques on how to deal with it. So there are different ways to deal with it, whether it's undersampling, oversampling, and that's not what I will focus on today. What I will talk about is what does that mean for the evaluation metric. What that means is that the accuracy of the model is not a good indication of how the model is performing. Let's say you have an 85% accuracy. It sounds good. 85% accuracy sounds really good. But in fact, if you have 85% of the observations for employees who are likely to stay, then that doesn't make sense, right? So again, if you have a model that always predicts that an employee is likely to stay, so that's all that the model is doing, it always predicts that the employee will stay, it will have an 85% accuracy because 85% of the data is about employees who are likely to stay. So what does that mean? So it means that we need to find other metrics and other ways to evaluate our model. So I'm going to focus on just two metrics here to not overwhelm you, and we're not going to focus on the math as much as the meaning behind these metrics. We're going to talk about recall and precision. So recall is the ability of the model to find out all the people who are going to leave. Okay, so recall is the ability to find and to, let's say, recall or discover all the cases and observations that are going or are very likely to leave. And precision is about how precise the model is or how correct it is when it says someone is going to leave. So let's again recap that. So recall is the ability of the model to identify the cases where a person will leave, versus precision is the ability of the model to correctly predict that the person is leaving. So there's a trade-off here, because the higher the recall, the higher that, and the bigger the chance is that the model is being able to identify all these cases where someone is going to leave, the more likely it's going to make some mistakes. So sometimes it will say that someone is going to leave, but in fact, it's going to make a mistake. So the precision will be dropping. And the other way around, the more the model is precise and the higher the precision, the lower is the recall is gonna be. So let's say if a really precise model means that every time the model says someone is gonna leave, it is 100% sure that this person is going to leave. And what that means is that it's not going to recall all the cases, because this is almost like a risk-averse model. It's a model that doesn't want to make mistakes, let's call. So it will only show you the cases where it's very, very likely that this employee is really going to leave. So we're going to talk about that now, and I'm going to quiz you and make sure by the end of this you will really differentiate between both of these metrics. The question here is, what is the right balance? Do we go with precision or do we go with recall? And that is basically what I started with saying. This is why you need to really understand what's the end product, or what is the objective of this machine learning model. What are you trying to achieve? Because based on that answer, you will be able to choose which evaluation metric you need to go with. And another metric is called the F1 score, which is more like a weighted average between the recall and precision. So if you wanted to balance out between the recall and precision, you will choose an F1 score. So now, hopefully you're still with me, because we are going to launch into a question. So if you are still here, we're going to go through that. And if you left, you can go back to menti.com and use this code at the top. Okay, so the question now is, for the employee attrition model, predicting employees who are likely to leave, which evaluation metric should we choose? And remember, we're dealing with imbalanced data. So you have precision, recall, F1 score, accuracy, or depends on how we intend to use this model. 5 seconds left. Okay, right. So it's going to be how we're going to use this model. Um, so for people who can't see the code on the top, it is 45249633. So I'm just going to wait a minute to make sure everyone sees that. So you go to menti.com and then you use this code for 5249633. I also shared it on the chat. Okay, now we're going to start with the third question. And now I'm going to give you a scenario. So let's assume we're going to create a dashboard showing all employees and the risk levels of them leaving, and then the manager will analyze the results. So again, your final output is just going to be a dashboard, and then you need to choose which evaluation metric you want to go ahead with. Is it the recall, precision, F1 score, or accuracy? Okay, it's actually the recall, and it's a tricky one. It definitely is not a black or white, so that's up to you to really decide. But logically speaking, if you are just going to have a dashboard, remember that recall is let's say, the model being risky. So it's the model trying to give you as much information as possible, but it's not very decisive. Precision is more for decisiveness, and precision is more for a very risky, risk averse model. So when you prioritize precision, you're really trying to say, okay, I want the model to give me the right information. I want to take this information and immediately take action. With recall, it's almost like you're telling the model, I need as much information as possible. Because remember, with recall, the model will likely spot all of these people who are likely to leave. Okay? But some people might not leave, so it might make that mistake. So now we're going to a second scenario, and that's going to be the final one. And we're going to look at another scenario where we're making a decisive model. So the model is you want the model to predict if the employee is likely to leave or not. And you want this model to be very decisive. So whatever answer the model gives you, you're just going to use it. So let's say immediately the model is going to give a salary increase, or will send someone for a training. And now you have to tell me which metric will you choose. So precision, recall, F1 score, or accuracy. Okay, 3 seconds. All right, so precision. And again, this one is not black or white. So F1 score might be also the right answer. But in that scenario, you're almost saying, okay, the model needs to make an immediate decision. You don't want it to be risky. You want the model to be precise. Precision means that every time the model says this person is leaving, then it's true. This person is very likely to leave. So this is why we choose precision here, because you want a model that immediately takes action. This is in real life, this is not likely. You will always need a human to analyze it and really make the action. And it might be that F1 score could be better here. Accuracy would definitely not be the best one here, because as we talked about, this is an imbalanced data set. So even if you had an 85% accuracy, the model might not be good, because then if the model is always saying this person is going to leave, and that's all that the model does, predicts that a person is going to leave, predict a model, the people are going to stay all the time, then it's not a really accurate or not a really reliable measure, because then it's telling you the model is accurate, but what it's doing really, it's always predicting a person is staying. So that's it for the evaluation metrics. It's definitely, it can be an entire session about that, but I just wanted to give you the main takeaway for me here is to notice how the business objective and what you're trying to achieve immediately impacts what evaluation metric you are going to choose for your project. And that was it for the quiz. And now we're going to see the winner, and we're going to move on to the next step, which is getting the data. All right, so Ahmed is the winner. Congrats. Now moving on to the next bit, which is, okay, so before we go to the next bit, a quick tip from me is around communicating with your users and stakeholders to understand what is it that you want to give them. They might want to see a dashboard. So in that case, you might think, okay, so that means probably the best evaluation metric is a recall. They might want to have a decisive model that is very precise, and they just immediately take action and train and give the employee more training, or give them a salary increase or a promotion, so that they give them an incentive to stay with the company. And that means probably precision is preferred. So that is the main takeaway, and you need to decide whether it's better to under predict or over predict the target. And that's basically for the first section, which is framing the problem and choosing evaluation metrics. We're going to talk quickly about getting the data, because I want to get to this part because it is very important as well. But with getting the data, you need to think about how much data do you need for your problem, where do you get this data, how much space it will take. And because we're dealing with sensitive information about employees, you will definitely need to check legal obligations and regulations about data privacy. And you will need to see if you can even get the access and authorization. You might find ways to protect the data, and ensure that sensitive information is deleted or protected, and so on. And the most important things, which is the last one here, is to sample a test set and put it aside, never look at it. That's super important, because ideally, when you want to take this model to production or launch this model, it will see new data that it has never seen about new employees coming in the company, and so on. So you want this test set that you put aside to be that kind of data set for the model, a data that the model has never seen throughout training, to make sure that the model can, make a good generalization and not overfit. So we're going to talk a bit about that later when we talk about evaluation. The most important thing here is really think like a human. So just think, when an employee is likely to leave, what are some of the things that might influence this decision for a person to leave? And you can do some research, then ask yourself, where can I get this data? Is this data in our systems? Is this data available publicly? So this is an exercise that you need to go through, and it requires a bit of research. You might think, maybe I need to gather satisfaction scores for employee. Maybe I need to get employee data, financial data around the salary, industry data. But at the end of the day, whatever data you collect, it has to be relevant for your problem. You're not just going to throw data and you're going to augment your data for nothing. It has to be data that is relevant for the problem you are trying to solve. And then after you gather all this data in, of course, usable format, and it has to be stored somewhere, you can explore it, prepare it, and do some feature engineering. And all of that exploring and visualization will be only on the on the training and the validation set. So you will not look at the test set as we agreed. Now, this normally is the section that requires the most effort. Let's say maybe it might be the most time consuming in a machine learning project. It requires the most effort because it's a lot of analysis and times, and we'll see some of the steps required here. Of course, in a best case scenario, you will have really clean data, you will not have any missing data, and that's why working with artificial data sets can be nice. But in real life, you might have missing data, you might have a lot of issues, which we will talk about. Because remember, the way we capture data these days is not as always advanced. Even though the technology is here, human behavior did not catch up yet. So sometimes we still use pen and paper, we might miss a field, we might enter things on Excel sheet, and we might just make a typo. So all of these things that generate error will not help our project, and we will need to do something about that. So we will need to fix all of these things before we even think about creating the model. So the first thing I'm going to talk about is some of the steps, and then we're going to talk about data types and data characteristics and some of the issues that we might face. Now, for every attribute, so for every column in the data set, so let's say for employee data, you are gathering age, salary, years of experience, and so on. You need to look at the characteristic, you need to look at if there is missing values, if there are outliers, and we're going to talk about that in details. And then you can also, from the data that you have, extract or identify extra data that might be useful. So that's the first thing. Now, variable types, so that's going back to basics. You have three variables types. So you have numerical, categorical, and date and time. When we talk about the numerical data, you are talking about discrete or continuous. So some example for discrete variable types are round numbers like years of experience, family size. You will not have a family size of 3.2, for example. It will be like, let's say, 3 in total, or the household will be 3 people. With continuous, however, it will be floats. So it will be like GPA. It can be 3.2, it can be 4.0, it can be 2.7. So again, it's continuous, it's float. And then you have with categorical, nominal, and ordinal. Nominal are categories like gender. So for example, you have female or male. You might have with ordinal some sort of order. So let's say at a company, you will have grades or levels. So let's say you have grade 10, 11, 12, 13. So there's some sort of an order. You will also, for example, have in some companies associate, senior associate, manager, senior manager. So again, there is categories, but there is some sort of leveling there. And finally, you have date and time. You will might be familiar with timestamps, which include date and time in the same category. So now we will talk about the some of the things that we might face, and we'll talk about the characteristics of these variables, starting with missing data. So when you have missing data, you always need to do something about it, whether that's removing it, so removing the observations completely, or relying on some imputation techniques, so filling in the data in a way that makes sense. And it's really important to understand why the data is missing, because the imputation techniques will vary. So if the data is missing at random versus if it's not missing at random and there's some sort of a variable. So let's say all people who joined from a specific location to the company filled a form that did not ask for the age, let's say. So then you're gonna have a relationship and it's not gonna be at random. You're going to understand that all people who joined there did not fill in their age. So that's why it's missing. And then based on that, you can decide what imputation technique you can use. Sometimes you can use the mean. So you would just get the mean of age and you can just fill that in. And there are other techniques. Sometimes if it's a very small percentage, let's say if you have less than 5% of the data of the observations have some missing data, you can remove them. So it really depends. And sometimes it's a bit of trial and error to see how that imputation technique affects the performance of your model. The next thing we are going to talk about is cardinality, and cardinality is the number of different labels. So variables that have low cardinality are like gender. You have female and male. There aren't so many options. So that's a low cardinality example. High cardinal are when you have cities and postcodes. You might have lots and lots of cities. So the variables then with high cardinality might have some impact, especially on some algorithms. So again, these characteristics might have an impact that is different from one algorithm to the other. So let's say because we're talking about employee attrition, we are likely to trial some decision trees or other tree-based algorithms like random forest. And high cardinality might impact the performance of tree-based algorithm. So you would need to do something about them. So what you can do is to do some encoding or aggregate some of them and bucket them into other categories. So instead of having 20 cities, you can aggregate them and then you can reduce the cardinality. Similarly, with their labels, if you have really small percentage of the observations with their labels, they will also affect tree-based algorithms. So for example, let's say we're talking about city names, and let's say you are looking at where the employee is from. Now, of course, cities with very low population, like let's say I'm from Tripoli, Lebanon, you will probably find very small percentage of the observations are from people from the city, from Tripoli, versus if it's people from New York or a more populated city. So that's something that you need to keep in mind. Again, it makes it more difficult, and tree-based algorithms are sensitive. So you can either remove the observations with these, let's say, city names, if they are rare labels and they don't appear that many times, or you can aggregate them. So you create a new category, you call it others, and then you put in all the rare labels in. So all the cities, let's say, that have very small observations or small percentage. And then we can move on to outliers. So outliers are also, I think they don't impact tree-based algorithms as much, but maybe they impact algorithms like logistic regression. And again, it's a matter of trial and error. But an outlier basically is any value that is outside of the 25th and 75th quant, from the data. So it can be, let's say, if we're talking about age and you have everyone from the employees is between 20 and 35 or 20 and 40, and then you have one with the age that is, let's say, at 64, then that is an outlier because it's outside of a specific range. Then finally, you have variable magnitude, and this is really important because that also impacts the performance of the machine learning algorithm. And it's really important here to do some feature scalings because features with or variables with high magnitude will tend to dominate other variables. So it's really important to do some scaling. So that's it in a nutshell. This is not very exhaustive because honestly, from one algorithm to the other, the sensitivity will change. But my point here is to put some of the biggest issue you might face on a slide, and then you can really figure out next time you face missing data, what is it that you need to do? It's not always the same answer. You just need to figure out based on the case you're dealing with, whether it's classification, what kind of models you want to try out, and things like that. So that's basically just a summary on some feature engineering and some of the things you need to be aware of. The next thing we are going to talk about is creating the model. Now, in that case, because we're talking about predicting employee attrition and it's a classification problem, you can list down some classification algorithms that you want to try out. So let's say decision trees, logistic regression, support vector machines, and so on. Then you need to evaluate these algorithms on the chosen metric that we choose. So let's say we said we're going to look at F1 score. We're going to see how the model or different algorithms perform. And here it's really important to split the data or the training set into validation and testing set. And the reason is you want to see what's whether the model is overfitting. So with the validation data set, you will be able to see if the model is performing really poorly. If you have really good performance on the training set and really bad performance on the validation set, that means that the model is overfitting. And you want to have, of course, with the validation data set, the performance will drop, but it should still be a good performance to be able to say, okay, the model can generalize, it's not overfitting. So that's the whole reason behind having a cross-validation set. The other thing we're going to talk about is hyperparameter tuning, and there are different things we need to think about here. So one of the first methods that you might hear about is grid search. Now, grid search will help you find the best combination of hyperparameters. And the way it works is that you define an equal range for each hyperparameter. Then what grid search will do is to automatically brute force and try every possible combination and then output and choose the best combination. But the problem is that it does not consider past evaluation. So it's doing this brute force without learning from every iteration. With random search, it's, as the name suggests, it's randomly select a predefined number of combinations, and then it is faster than a grid search, and that's the good thing about it because it doesn't have to brute force and try every possible combination. It's more of a random thing, but it also doesn't consider past evaluations. And then finally, you have the Bayesian optimization, and it is more efficient because it helps select hyperparameters in an informed manner. And basically, the way it is different is that it prioritizes hyperparameters that appear more promising from past results. So it learns and it can find the best hyperparameters in less time. So it's also even faster. So that's it in a nutshell around hyperparameter tuning, and these are different methods. The next thing we're going to talk about is presenting the results. So at that point, you would have framed your problem. You have a very clear understanding of what the problem is. You got the data that you need. It's stored somewhere. It's structured. It's you explored it. You can already see some of the, let's say, other than the correlations and other, you can already see some insights just from exploring the data most of the times. Then you prepared it and you did some feature engineering. You looked at different characteristic of the variables and you made sure that the data is pre-processed. Then you created the model. You shortlisted some, let's say, promising models based on the evaluation metric that you chose. And finally, you did some hyperparameter tuning, and then you're ready to present the results. So that's before the launch. That's when you want to show the results of your solution so far, or let's say your work. And in this section, it's really important to tie things back to your business problem. Because when you're summarizing everything that you did, so what I talked about now, the important thing, as I mentioned, is the output of this work. So it's the so what and the next steps of what you're trying to do. So you're basically tying things back to the business value. We also talked a bit about the UX elements. So when we talked about design thinking, this is all based on user research and core principles that will help you identify and frame specific problems that are worth solving. And you are throughout working closely with your stakeholders, making sure that every time you want to make a decision, you're making sure that it's aligned with the big business objectives that you need to deliver to. And of course, we talked about a lot of technical elements that you need to tackle and how they all of these aspects converge and they all intersect. And this is exactly where your solution should be. It should answer all of these elements because you want a solution that is business viable, which either saves money or generates revenue. You want it to be feasible, it's something you can do. And of course, you want it to be desirable. You want to build a solution that someone actually wants to use or it will benefit them and answers their objective. So that's basically the end to end. There is so much more to it, but that's one a quick overview on the different steps. I'm aware that you have a session after, so I wrap up the session early and I won't take now questions and answers just because you would need probably a 10 minutes break before joining the next one. So what I left for you is a QR code that you can scan and you can post your questions, given we don't have the time for Q&A. And then we can get back in touch and I can read your questions and respond to you. And that's it for me. So thank you so much for having me. I will look forward to see your questions and feedback.